continue on with proofs today. You may use definitions, postulates, properties, and theorems as reasons in your proofs. So on the right-hand side of your column, you can use definitions like linear pair. Postulates. Postulates are just concepts that we've been given in math that mathematicians have seen over and over again, but they cannot actually make a proof for it or prove it. Cannot, well, I should be writing be proven. Unlike theorems. Theorems you can actually do a proof for and prove that it works. Okay, so those are the 4 things you're allowed to use in your proof. Please make note of it. Here's one more proof to give us a little bit more of an example of what a proof looks like. First step is to take a look at the diagram, and you'll notice in the diagram here we have 2 angles. They do not create a linear pair because there's no line created by them. And it looks like this ray over here in the middle might be in the, well, like I said, might be in the middle. Let's take a look at the information here. It states that we need to find what is the value of x. So we look at the picture, can't quite get any more information by looking at it. So we go back into the reading. It says given AB bisects. So ray AB bisects RAN. So we write that down as a statement. Ray AB bisects angle RAN. If it bisects it, that part is given. If the word bisect there, can that help us out maybe? It means to cut into 2 equal parts. So if we look at this, that means that AB here, this ray, cuts the angle into 2 equal parts. So that means, what do you think? The angle RAB, which is highlighted here, RAB must be the same size as angle BAN. Trying to highlight it there, didn't work out so great. Those angles must be the same because we know the definition of angle bisector. Bisecting this angle, definition of angle bisector. Why did I suddenly write down expressions here? Well, I took RAB, which was angle, had x degrees in it, and angle BAN, which had 2x minus 75 written in it, and I just substituted. Now I'm starting to get somewhere. I'm getting down to being able to find the value of x. Now I just simply use algebra skills. If it says x equals 2x minus 75, the next step I want to do is I want to go ahead and subtract my 2x from both sides. If I subtract 2x from both sides, I'm left with negative x equals negative 75. Okay, so definition of angle bisector was the reason I wrote down the 2 angles equal. Then I substituted in the information from the diagram, so I write substitution. Then I subtracted 2x from both sides, so I wrote subtraction property of equality for that. Now, I wrote simplify here. That really shouldn't be there. So we need to go ahead and get rid of that. So we'll just go ahead and mark that out. I already wrote down my reason for writing negative x equals negative 75. It's subtraction property. Let's go ahead and take a look at the next step. If these are negative x equals negative 75, I still need to get x. My goal is to get x. Negative x, how can I change that to be a positive x? If I multiply it by a 1, and I multiply this side by a 1, wait a minute, how about a negative 1? If I multiply both sides by a negative 1, I will get a positive x and a positive 75. And, oh, subtraction? Did I do subtraction? No. What did I do? I multiplied both sides by a negative 1. So this should read multiplication property of equality. Once again, our steps were to look at the diagram, noticing that two angles look like they're about the same, and then I think, I better have proof of that. I look in the writing, it says AB bisects RAN. So they are the same size, so I set the angles equal. I substitute their angle measurements in, and I solve for algebra and solve for x using deductive reasoning. Once again, just to make sure that you understand, usually the first step is a given statement, and the last step is what you're supposed to prove. So as far as notes go for this, please go ahead and just write, oh, for some reason that didn't work. Give me a second. Statements, reasons, theorem. Number one is usually your given. Now you're not going to write given, but whatever they gave you gets written here. And then the last step, let's just call it step 5 for this case, is whatever they say you're supposed to prove goes in here. Okay? Please don't write prove. Whatever they give you in the information up above, that's what goes in. Look at what they did. Given and prove. And that's what you can write down as a note. Just understand that the given is usually the first step, and whatever you're proving is always the last step. These are geometry properties. They are given to you on your worksheet, also in your book. The reason they're geometry properties, notice they're talking about segments here and angles. If AB equals AB, that's reflexive property. If angle A equals angle A, that's reflexive property. Symmetric property is when you do the switcheroo. AB equals CD, switch it. CD equals AB for the second step. First step, if A equals angle B, then second step, angle B equals angle A. Switching is symmetric. Transitive property, AB equals CD, CD equals EF. And we'll notice we have the CD written twice. Therefore, AB equals EF. That's their logical conclusion. Those are geometry properties that you can use as reasons in your proof. All right, let's take a look at applying those reasons in a few problems. Take a look at this. This is like step 1 here, and this is step 2. What happened? If you look at the problem, you notice it has variables in it. It's an algebra problem. What happened? It was 2x, and the plus 9 suddenly disappeared, and 19 became a 10. So they must have subtracted 9 from both sides. They subtract 9. What property is that when you subtract from both sides of the equation? If you subtract from both sides of the equation, that's, oops, I thought that might work, sorry. Get the arrow. That must be subtraction property of equality. Let's go to part B here. Oops, leave that up. Angle O is congruent to angle W. Angle W is congruent to angle L. Ooh, W is written twice, and then they suddenly say O is congruent to L. So if O is congruent to L, which property was that we used? Notice this goes, W is written twice, O is congruent to L. That's going to be transitive property. The next one, E equals T for the first step. Angle T equals E for the second step. What did they do from the first to the second? They switched them. Switching, symmetric. That must be symmetric property. Okay, last little grouping for this video. AR is congruent to TY, and segment TY is congruent to AR. What happened from step 1 to step 2? Looks like a switch. Which one is the switch? Do you remember? Symmetric property. Take a look at this problem. You notice it does not have angles or segments. It has actual algebra information. It has variables. How did you used to do this in Algebra 1? 3 times x, 3 times 5. What was the name of that property? We didn't list it yet. It starts with a D. It's called distributive property. Now this last one, dealing with a fraction, it has 1/4 x equals 7. How do I get rid of this 1/4 so I can get x? Well, if I multiply both sides by a 4/1, the reciprocal of this 1/4, multiplying. They will cancel out. These cancel and you get 1x. 7 times 4 over 1. 7 times 4 is 28. Divide by 1. 28. You can also look at this as, what is 4 divided by 1? Well, that's simply a 4. So 4 times 7 is 28. So, therefore, what did I do there? I multiplied both sides. So what property? You know it. Multiplication property. Okay, that concludes this video. And thank you for taking your notes.